Laws of limiting friction. First one. First law. Limiting friction depends on the limiting friction. Limiting friction
Their surface.
depends on the what?
Static.
The
Maximum friction.
nature of the surfaces. Nature of the surfaces in contact. Okay. For example, the given table, if I place wooden block, instead of wooden block, if I put some kind of a stone, then do you think that it is both same static friction here? Suppose if I
No,
put
sir.
stone, if I put metal block instead of wooden block, if I put a metal block, do you think that same amount of weight is required?
No,
No,
sir.
sir.
No, it may be
No, sir.
increases or maybe decreases also. Clear,
Yes, sir.
everybody? So the surfaces, depends upon the surfaces, the limiting friction changes. Is it okay, guys? Everybody clear? Yes?
Yes, sir.
That is what. So the limiting friction depends on the nature of the surfaces in contact. Nature of the surfaces in contact, comma, provided normal reaction remains the same. Provided normal reaction. Yesterday we studied normal reaction. Ellame theriyuma? Normal reaction, yes, remains the same. So that is what it is. Second one. For example, For example, let me take example now, all of you. So when if you notice it, when a ball is given the same initial velocity on two different surfaces. For example, Mr. Mari created one surface, Mr. Sanjay created another surface, and Mr. Lingesh created another surface. Mr. Kishore will create another surface. Totally how many surfaces now? Everybody? Four
Four,
surfaces.
sir.
Now you tell me, the body is projected with the same initial velocity, u1. Here also body, same u2. And here also initial velocity u3. And here also body is u4. So I will say u1 is equals to u2 is equals to u3 is equals to u4. Means in the sense of all the initial velocity is what? Same. So now, do you think that all the four surfaces body covers the same distance? That is what is my question. Is it will cover same distance? That is what is my question.
No, sir. According to the surface, sir.
Is will cover same distance in all the four surfaces?
No, sir.
No. Clear, everybody? So some surface may be
Depends on the
exert more
surface.
friction, or some surface may exert, yes please,
Yes.
less friction. So it will be depends on what? Static friction. Sorry, limiting friction is always depends on
The
Surface.
surface.
Clear? But next point you read. Normal reaction remains the what? Normal
Same.
reaction remains the what? Same. Understanding?
Same.
So for all the bodies same, so that normal reaction is remains same. But the distance traveled by the body is not equal. Do you all understanding? Because same mass, same reaction. Because weight is equals to same. Am I right or wrong? Same body, correct? Respond, all of you. So if it is the same body means what
Yes,
is the
sir.
normal reaction? Normal reaction remains constant or not? Mari, Lingesh?
Yes, sir.
Yeah, N is equals to what? Yesterday
Yes,
we have
sir.
studied. N is equals to what? Normal reaction is equals to weight. This is what? Mass into gravity. Am I right or wrong?
Yes, sir.
Yes, sir.
But the distance traveled by the body, is it same? No.
No, sir.
Okay. That will depends on surfaces. That will depends on what?
Surfaces.
Surfaces. That is what you have to remember. That is the first law of limiting. Next. You all clear? Everybody?
Yes, sir.
Yeah. Next. Second one. The force of limiting.
So one doubt, sir.
Yes.
It also depends on the force applied on the object, no, sir.
That is what I given initial velocity, Mari. Same initial velocity. Same initial velocity means applied force is same only, correct, Mari?
Yes, sir.
That is clear. The force of limiting friction. All of you write it. The force of limiting friction varies directly as the normal reaction. Varies directly as the normal reaction. So means normal reaction increases, then limiting friction also increases or decreases? Limiting friction is also increases or decreases?
Increases.
Increases. For example, pakranga diagram again. For example, I will put instead of wooden block, I will put a metal block. In which case weight is more? Anybody can tell? For example, wooden block, weight is equals to mass into G, so that normal is equals to N, so that N is equals to mg. Now tell me, another block, instead of wooden block, I will put an iron block. Now iron block means weight increases or decreases? Let me take capital M. So this is small m. So weight is increases or decreases? Iron box, iron block means, all of you?
Increases.
Increases. So by that time, N is equals to capital M into G. Now, do you think this mg and this mg is equal? Do you think this mg and this mg is equal? No. Am I right or wrong?
No.
Everybody, respond, Ra. All of you.
Yeah, no.
So, understanding, if I use iron block, different weight. If I use wooden block, different weight. Then, the weights which will make them to move is also varies. Am I right or wrong, guys? Agree with me? Yes or no?
Sir,
All of
and then,
yes,
sir,
Mark.
then the normal,
Huh?
sir, then the normal will be equals to mg or not, sir?
mg only, Mari, but mg is not equal. Am I right or wrong? If I put wooden block, for example, wooden block is 100 kg, for example. So 100 kg into 10, which is equals to 1000 newtons. So normal reaction, N is equals to what? 1000 newtons, for example. If I took iron block will be same 100 kg. Definitely it will be more kg. Let me take iron block is 500 kg. Now tell me, what is the normal? 500 into 10, which is equals to how much normal? 5,000 newtons. Right or wrong? So that is it normally same? Is it normally same, Mari? That is what I'm asking.
Yes, sir, same.
Our same, normal is not same. Here 1,000 newtons and here 5,000 newtons. Is it same?
No, sir.
That is what I'm saying. So normal is limiting friction also varies. F limiting is also varies. Both are directly proportional to each other. If normal increases, limiting friction is also increases. If normal decreases, limiting friction also decreases. Both are directly proportional to N. That is what is the statement. Clear? Understood, Amma? All of you? Please respond. Yes, that is what. So I am speaking about limiting friction, not static friction. Why? I am speaking about limiting friction, not static friction. Static friction is a what? Constant or variable?
Variable.
Static friction is a constant or variable? Everybody.
Variable.
Variable.
But maximum static friction, what we used to call? Maximum static friction. That is only called as what?
Limiting friction.
Limiting friction. Understand? If you want to make the body to move, you have to apply the force more than the limiting friction or less than the limiting friction?
More than the limiting.
More than the limiting friction. So the force of limiting friction varies directly as the normal reaction. Means, can I say the relation F limiting is directly proportional to N? Am I right or wrong?
Yes, sir.
Yes, all of you. So N means what here? N means what it is here? Normal reaction. For example, you want, you can take it, guys. Don't get confused. I'm taking a one bench and I'm taking another bench. So one place I place the wooden block and another place I place the iron block. This is iron block, and this is the wooden block. So in this case, mass is mg. Understanding, let me take normal is n or n1. So n1 is equals to mg. Now, in this case, mass is capital M. Let me take, this is capital Mg and normal is N2. So that N2 is equals to capital Mg. Do you think that N1 is equals to M2? N1 is not equals to what? M2. Am I right or wrong? Everybody. Because the weight of the body is not equal. Because wooden block is less weight. Iron is what? Iron is what? Everybody. More weight. Yes, please respond, Ra. Now, if I want to move this body with the help of pulley, then I need to put more weight or less weight here. Here less weight, And here what weight I have to put? More weight or less weight?
More weight. More weight.
More weight.
Because as it is more limiting friction. Normal reaction is more limiting friction. I have to put more weight or less weight? Agalya. I have to put
More weight.
understanding, Amma? Agalya? Clear?
Yes, sir.
That is what. So,
Sir,
F
sir, can you please say it again?
which one, Mari?
Sir, diagram explanation.
That's what. Now here wooden block is having normal reaction is N1. So that limiting, let me take F limiting is also something. Here also F limiting, FL2, let me take if FL1. Now what you think more? Limiting friction of wooden block is more or limiting friction of iron block is more? Which one you are thinking more? Everybody.
Iron block.
Iron block will be more because of normal reaction is greater. So that more weight is required to drag it down. Understand, Mari? Make it move and coming down here. So we have to put more weight on the palm. Okay, measuring pan. Understand, Yara?
Sir, in the second law, they are saying that limiting friction and normal reaction are directly proportional.
Proportional to each other. So normal reaction increases, limiting friction also increases. So that you have to put more weight on scale pan or less weight on scale pan to make it move. More weight. Am I right or wrong?
Right.
Clear, Amma?
Yes, sir.
Girls? Understand, Amma? Abhirami? Are you there in meeting? So
Yes, sir.
we need more weight to make it move. So that is what. Now in mathematics, many times I have taught you. If you want to remove the proportionality, we need something. Anybody can tell? We have to bring equals to sign. What is that? We have to take something called as constant. Am I right or wrong? I will replace the proportionality constant with a equals to sign. Then I must take the constant. Constant equals to into constant is only called as proportionality. Proportionality constant into n. Now this constant only we is to called as mu s. What is to call, everybody? Mu s. Small subscript s. Mu s. So mu s into n, which is equals to f limiting. This is the formula for calculating f limiting. All of you note it. F limiting is equals to mu s into n. N means what, guys? We all knows that. What is n? Normal reaction.
Normal reaction.
FL means what? Gokul?
Normal for
FL means maximum static friction. That is only called as what? F limiting.
limiting for
F limiting. Okay, that is what. So F limiting is what? Body is ready to move, tends to move, but it is not said to be in. But it's not said to be in what? Motion. Understand, Emma? Everybody? Respond, Ra. So this
Yes.
mu s you should write like this. Mu and subscript s. Mu s means it is actually a constant. That constant tomorrow we will find it. Understanding? So that is what we used to call as coefficient of static friction. What we used to call, everyone?
coefficient of static.
Coefficient of static friction.
Coefficient.
Okay. So we all people knows correct proportionality. If you remove, you can make it equals to sign. Am I right or wrong? Theriyuma theriyada? Yes, with a constant. That is what it is. So even Newton's second law we have been made. Force is directly proportional to, that is what, change in momentum divided by change.
P1 by P2.
So if you remove that proportionality, if you want to bring the K constant, that is what K into MA, and experimentally K value is equals to how much? I have told you. Experimental value K is equals to 1. So that what is the Newton's second law? F is equals to MA. You remember all of you? Yes. That is what. So that same way here K is a constant, same way here mu s is a constant. What is the mu s? Coefficient of what?
Static friction.
Static friction. That is what. What is the formula for F limiting, everybody? Mu s into n. Okay. This is the second law. And last one is third law. The limiting force, write it. The force of limiting friction. The force of limiting friction is independent, not dependent, independent of the area of contact provided normal reaction, provided normal reaction and nature of the surfaces remains constant. So that is what is F limiting. Means the force of limiting friction is not depending on the area of the contact. So they will always will be remains constant in the sense of between the same surfaces. That is what? The nature of the surfaces remains constant. Then the F limiting is also what? Everybody. F limiting is also, respond Ra. F limiting is also what? Constant. Okay. For example, see, I will take an iron block on a bench. Iron block. So this much area is contacting. Now I will take another iron block. Like brick therima, we all people knows brick. We have made a cuboid shape. Do you all remember everybody? Yes or no, Mare? Pressure sums.
Yes, sir.
So now see that
Yes.
much area is contact here. Now I will take another same iron box where only less area is contact. Less area is contact. But still, what is the limiting friction? Here less area is contact, here more area is contact. But still, F limiting is what? Same. That F limiting is maximum. That is what? Maximum static friction. Maximum static friction, Fs, is remains what? Remains
Same.
constant.
Same.
Okay. So remains constant. Why? Here also bench, here also iron box. Iron metal. Here also bench, here also iron piece.
There is also
So,
iron metal.
yeah, iron only. So same surfaces, but area of contact is different. So that is what area of contact, the force of limiting friction is independent of the area of contact, provided normal reaction and N is nature of the surfaces remains constant. Why means pakranga. Here also, what is the weight? Weight is equals. Let me take this way. Mass is equals to 10 kg. And here also, what is the mass, everybody? Here also mass is
10
how many kg? Same 10 kg. So weight is equals to 10 into 10, which is equals to 100 newtons. So normal reaction is remains same. So N is equals to how many newtons? N is equals to W, 100 newtons. Here also, what is the weight? Weight is equals to same 10 kg into same 10, which is equals to how many newtons? All of you. Same 100 newtons. So here also N is equals to mg, which is equals to same 100 newtons. So have you noticed it? It is independent or dependent? Area of a contact. Yes, please. Limiting friction is independent or dependent, guys? Area of a contact?
Independent.
Independent. Understand, Nivedan, Lingesh?
Sir, independent in the sense how you are saying it, sir.
Because here more area is contact, but still the limiting friction, we got it same, normal reaction. Here less area is contact, but still the normal reaction is remains constant. Am I right or wrong, Mari? So if normal
Yes, sir.
reaction remains constant, so the F limiting is also remains constant. That is why it is independent. Clear, Sangamitrai, Princey, Mr. Sam, Hasinis?
Yes, sir.
Yeah.
Yes,
So
sir.
this is what you have to understand. So this is what is static friction. So in static friction only, if the static friction is maximum, we used to call it as what? Everybody. We used to call it as
Limiting friction.
limiting friction.
Limiting friction.
And
Limiting friction.
limiting friction is only the friction, always maximum value. Limiting friction is one maximum friction compared to static friction. And as well as next one is rolling friction. Of course, why is a rolling friction less? We will discuss it. Okay. So this is what about the today's class. I hope you all enjoyed and you learned something today. Then tomorrow's class we will study experimental verification of loss of limiting friction. And then we will go with the next type of friction called as types of friction. That is what? Kinetic friction. So kinetic friction is two types. One is what? Sliding friction. Another one is what? Yes,
Rolling friction.
rolling friction. Okay, sliding friction only we can call it as dynamic friction, or we can say even kinetic friction. And next type of friction is rolling friction. So we'll study what is this frictions and the formulas and all. So with this, I'll stop the today's class. I hope you all learned. Thank you. We'll meet in tomorrow's class. Thank you all of you.